Alright, this third item, we're asked to find the moment of this force at the end of this crowbar with respect to this point C where the nail is located. We're not trying to figure out what the force is on the nail, we're just asked to find the moment of this force. That force is equal to 30 pounds. It is oriented at 15 degrees from the horizontal, and so that's going to make this maybe a little bit more difficult. We're asked to find, this moment about point C, and so all we're really asked to find is some perpendicular distance to the line of action of that force times the magnitude of that force. The problem is that there's nothing easy there at all in terms of finding that perpendicular distance. And because that doesn't look very easy at all to me, what I'm going to do is instead break this into x and y components over here at point A, and then I'll just figure out where point A is relative to point C. And so there's your px and there's your py. Note that px relative to C is going to want to go in a clockwise fashion, whereas py has a line of action that is to the left of point C. A lot of people assume that for some reason that py must be going through C, but that's just not the case at all. Instead, we're going to have to find this little distance here. Now, we know that this angle down here at B is 70 degrees, so we can find pretty easily what this vertical height is. That's just going to be 18 inches times, and we're the opposite, so cosine of 70 degrees. And I got that backwards. Of course it's not cosine, it's the opposite, so that's sine of 70 degrees. We actually just found the base, which was what I was thinking about, but doesn't matter. Whoa. 18 times 70 sine, that's equal to 16.91 inches, right? And then this total base is 18 times, now that will be cosine of 70 degrees, and that's equal to 6.156 inches. So this leftover piece then is going to be 6.156 minus the 4, or 2.16 inches will be sufficient in terms of precision. Right? So when we do it that way, then all we need to do is find out what px is. That's going to be one of the components of p that we want. And so that equals 30 pounds times cosine of 15 degrees equals 28.98 pounds. Py will equal 30 times sine of 15 degrees that equals 7.76 pounds. And now we can then find what we really want, the moment about point C, by summing up all the effects. My intuition says that this big X component with this big moment arm is going to dominate, so I think things are going to go in a clockwise fashion. And so let's then take px of 28.98 pounds times that perpendicular distance of 16.91 inches, and then the py goes in the opposite direction, so that'll be minus 7.76 pounds times that moment arm of 2.16 inches. Okay, and let's see what we get. And we get 473.3 pound inches. We get a positive, meaning it's acting the way we assumed right here. So my final answer then will be the moment of about C of this requested item is a 473 pound-inches in a clockwise fashion.